Eighth grade. Today in science, we're going to build on what we learned in lesson 1 in chapter 7, and that's the actual practice of balancing equations. So we've got this balancing equations challenge in front of us. On the first side, it walks us through what we're going to learn as the process, and on the back side, we actually get to put together how to actually do this given the equations that this page has for us to work on. So part A says the parts and the pieces. Number 1, it asks you to circle each subscript in each chemical formula. Number 2 says draw a square around each coefficient, and number 3 says answer the question related to each chemical formula. So let's start with number 1. Circle the subscript. Remember the subscript, sub meaning below, is this little number here that indicates how many of these atoms there are. So there are 2 oxygen atoms where it says O2. Here's another subscript. Here's another subscript. This would say 2 oxygens. This would say 2 hydrogens. Now you'll notice there's nothing below this C here, so that just means that there's one of those. In the next equation, there's a 2 here that's referring to the carbon, and there's a 6 here referring to the hydrogen. The 2 here refers to the sodium, and the 4 here refers just to the oxygen, so it just applies to the one element in front of it. Number 2 says draw a square around each coefficient. A coefficient is a number that is in front of the atom, and it's in kind of full capacity. It's a large number in front of. That's a coefficient. So there's one here. There's one here, and there's one here. Now, how those coefficients work, it's kind of like the distributive property. You take that number and you multiply by the term behind it to say how many of those atoms or those elements are that exist. The subscript just applies to the one. The coefficient can apply to the entire molecule, so the entire set in this order. Now, number 3 says answer the questions related to each of the chemical formulas. What does the O represent? Well, if you have your textbook and you open up to the periodic table, the element symbols are there, so you can see that O is representing oxygen. Here in CO2, it asks us how many atoms of each element are in the formula shown. For carbon, there's no subscript here, so you can assume that it's just 1, and then for the 2, referring to the oxygen, there are 2 oxygens. This question says how many atoms of hydrogen are in this formula as shown. Now, the tricky part here is, again, how the coefficients work. The coefficient is multiplying by this entire atom, and the 2 is applied to this H. So there are 2 hydrogens in 1 atom of hydrogen gas, and there are 5 overall atoms, 5 overall molecules of that hydrogen gas. So you have 5 times 2, which would give you a total of 10 hydrogens. In the bottom question here, it says how many atoms of each element are shown in the formula. So the 2 applies to each of the letters, so the entire compound itself, C2H6, so you have to use the distributive property and multiply. So that 2 is multiplied by the number of carbons, so there are 2 carbons. 2 times 2 is 4. And hydrogen has 6 in 1 atom, and you multiply 2 times 6 is going to give you 12. So you take this coefficient and multiply by whatever the number of atoms are in 1 compound of that element. Here you've got 2 Na2SO4. How many atoms each element are in the formula shown? So you have to think there are 2 sodiums, 1 sulfur, and 4 oxygens in 1 compound of that element, and then you're going to multiply each of those by 2. So 2 times 2 in this case is going to be 4. 2 times 1 in terms of sulfur is going to be 2, and 2 times 8 or 2 times 4 gives you 8 in the form of those oxygens. Okay? In this bottom question here, part B, it says label the chemical equation using product, reactant, subscript, coefficient, and yields. Here is an example of the different types of vocabulary terms that you need to know just to see how the equation is set up itself. As we learned in chapter 1, or in lesson 1, chapter 7, there are different ways in which products and reactants are represented. They can be represented in words, in their scientific names, in the chemical formulas, or chemical equations. Here, we're going to simply just identify where those parts are. Products, reactants, subscripts, coefficients, and yields. We know that reactants are what go into the equation, products are what are produced at the end, so we know what side of the equation those are on. The yields portion is going to refer to the arrow. It can also be assumed that this would say produces. So on the left-hand side here, we have the reactants. That's what goes into the equation as we're reading it from left to right. On the right-hand side, we have what are called the products. as we lead it from left to right. So we took care of products, reactants, and yields. Subscript and coefficient we just learned in this top section where those are and how to identify those in order to help us count the atoms. Here you've got a subscript because it's the number written below. And here you have the coefficient, which is the multiplication of the number of atoms that are in that compound. Now let's just check to see if this equation is balanced. We have to count the number of atoms on each side of the element. So here you've got 2 manganese. There are no subscripts, so you've got 2. And on this side you've got 2. So I would write these out, each of the different letters that I have on both sides, just like this. And I do it on the product side and the reactant side, and then I count them. So here I've got 2, and oxygen says O2, I've got 2. On the right hand side, this coefficient applies to both of these elements, so I've got 2 and 2. If I have both sets of these numbers equal on both sides, I have a equal or balanced chemical equation. Now that's important to get us started on what the back side of this paper looks like. Here it says balance each of the following equations, and I'm going to teach you what that looks like. We now know what the subscripts are and the coefficients mean. We now have to go through this practice of balancing the chemical equations themselves. That means we're going to be adding coefficients where we need to. We can't change any subscripts, but we can change the overall coefficient to make sure that these are balanced. What I like to do is to start out by using a pencil instead of a pen in this case, because I'm probably going to do some erasing when it comes to actually writing out these elements and changing the amount that I'm going to count. So the first thing that I do on each side of the arrow is create a list of the different types of elements that I have. Here I've got hydrogen and oxygen, and I set up this little equal sign to say how many are there. I'm going to then count them. Here there are 2 hydrogens and 2 oxygens, so I write that out, 2 and 2. There's 2 hydrogens and 1 oxygen because there's no subscript below this oxygen. So according to this, I don't have a balanced equation. I need to do something to change it. And the only thing that I can do is to add a coefficient. Add a coefficient means that you're going to put a number in front of any of these spots where you have elements that are separated by these plus signs. So I already have the hydrogens that are equal. I don't have the right number of oxygens, so I should probably in this case add a number to where I would increase the oxygens on the side that is below. If I put a 2 here, let's just see what happens. Now if I recount, I'm going to have to cross these out and recount. 2 is multiplied by 2 hydrogens here, so I have a total of 4 hydrogens. And 2 is multiplied by 1 here, so I have a total of 2 oxygens. Well, now I have oxygens that are balanced, and I don't have hydrogens that are balanced. So what do I do? If I know that I have an even number here, I can actually go back and I can add a number to this hydrogen, which would be 2 times 2, would cancel this out, and that would be a total of 4. After I've counted, now I have a balanced chemical equation. Bear with me, Mr. Shane needs to find a better pencil to use, or maybe a pen, just to be able to go over this to show each and every one of these in a more clear fashion. The next equation says H2O2, hydrogen peroxide, can be separated. So if you take your hydrogen peroxide that is used to clean your wounds when you've scratched your knee or you've cut yourself, and you just leave it out, the actual extra oxygen molecules inside of that will actually dissolve out of the liquid and it'll turn just into water. Here's the equation of what that looks like. Now, again, the first thing to do on each side is to create the list of the elements that are existing, so hydrogen and oxygen, and we create this little equal sign. On the other side, we create hydrogen and oxygen, and we create this little equal sign, and now we're going to think of the coefficients that can go here if it's not a balanced equation. We have to count them first. On this side, I've got 2 hydrogens, so I would say 2, and I've got 2 oxygens. On this side, I've got 2 hydrogens, and I've got 3 oxygens, 1, 2, 3. So 2 and 3. Obviously, this means that it's not balanced, so I need to add numbers to those coefficient places in order to balance this portion of the equation. I always like to try and add to make even numbers in this case, or to eliminate anything that would be odd, such as this 3. So if I've got a 1 oxygen here and I add a 2 here, that's going to multiply 2 times 2 in terms of the hydrogens and give me 4. And it's also going to multiply 2 by 1 oxygen and give me a total of 2 and 2, which is now 4. So if I cancel that, now I've counted again on this right-hand side to show that I have 4 of those total. Now to go back to the left-hand side, I don't have a balanced equation because I have 4 of each on this side and only 2 of each on this side. Well, how do I increase that? To get from 2 to 4, you just multiply by 2, right? So now 2 times 2 is 4 hydrogens, and 2 times 2 is 4 oxygens. Next equation. You've got sodium and oxygen to form sodium Na2O. Now let's go ahead and write out those elements on each side of the equation. Set up my equal sign, and then I count. Again, the first step is to count the number of elements on each side. You've got 1 sodium here. You've got O2, which means 2 oxygens. You've got Na2, which is 2 sodiums and 1 oxygen in this case. That means that I don't have a balanced equation, and I have to look to add a coefficient in front of these elements, or in this case compounds. Now to do this, I want to again eliminate where I have odd numbers. If I have 2 sodiums here, how do I get 2 sodiums on this side? I would think to say, well, maybe I need to add 2 sodiums here. I have 2 oxygens on this side and I have 1 oxygen on this side. How do I increase the oxygen? So I actually have to increase both of these. Is there a way in which I could increase that at the same exact rate? Now I'm going to show you a little trick here. If I know that sodium is being multiplied by 2 and I need oxygen to be equal to 2, I would probably just put a 2 here. Now let's see what that does. 2 times 2 for sodiums is going to change that to a 4, and 2 times 1 for oxygen is going to change that to a 2. Now I did that because I have got an odd number of oxygens here, and I have an even way to make this even because I can add an even number to each of these to balance that out. Okay, so I always like to add to the larger of the compounds and then kind of work with the more simple elements or molecules in this case to balance the equation. Now I've got 4 sodiums and 2 oxygens, so my oxygens are balanced. I don't need to add anything in front of this coefficient, but my sodiums are still only at 1. So I can take that and turn that into a 4 so that it balances out. 4 times 1 is going to give me 4, and now I have a balanced chemical equation. Okay? Let's keep going. In this case, again, we start with writing out the elements that are on each side. We set up our equal sign so that we can count where that arrow is. Here I've got N2, which means 2 nitrogens, H2, which means 2 hydrogens. I've got NH3, so there's 1 nitrogen and 3 hydrogens. What would that look like if I'm trying to change that around to make sure that I have a balanced chemical equation? Now I have to look at where I don't have things that are balanced. The nitrogens aren't balanced and the hydrogens aren't balanced, so I've got somewhere to start. Now I mentioned that I like to start with the larger of those molecules or compounds because then I can always go back and make easier changes where I know I have sets of 2 in terms of my molecules. So I'm going to change this one here. If I need 2 nitrogens on this side, I already have 2 nitrogens. How do I increase from this to be 1 to 2? Well, I put a 2 here because 2 times 1 is going to turn this into a 2 if I cross that out. And 2 times 3 in terms of the number of hydrogens, 2 times 3 is 6. Now that I've got these 2 even numbers, can I make these 2 match? Notice that the nitrogens are already equal, so I don't need to add anything here, but I do need to add something to my hydrogens. What times 2 is going to give me a total of 6? I'm going to put in a 3. 3 times 2 is 6. That changes my count here to 6. I've got 2 nitrogens on each side and 6 hydrogens on each side. I have a balanced chemical equation. We continue. Here I've got P4, O2, P4O2. P is our phosphorus. Now we have to write out how many we have on each side. There are 4 and 2. On this side I have 4 and 6. Now both of these are equal. The oxygens are not equal. So how do I change just the 1 oxygen to make sure that it's equal? What times 2 is going to give me 6? I think, well, if I put a coefficient 3, 3 times 2 is 6, so that would change this count to be a total of 6. And now I've got equal number of atoms on each side of the chemical reaction. The next balancing equation, you've got carbon and hydrogen. I've got 1 carbon on this side and 2 hydrogens. On this side I have 1 carbon and 4 hydrogens. Now to increase from 2 to 4, I could add a 2 here that would balance that out, right? But I always want to think about adding to where the larger of those elements or molecules or compounds are. So in this case, is there something that I can add here to make these balanced? But if I look, the carbons are already balanced, so I don't want to add anything here. I just want to add to where it's not balanced. That would be in the hydrogen. So if I add a 2 here, 2 times 2 is 4. I would recount that. Now I have 1 carbon and 4 hydrogens each to make that a balanced chemical equation. As you go down the page here, you'll notice that they're getting a little bit more complicated, a little bit more complex. That's all right, Mr. Shane's going to help you and walk you through each and every one of these balancing equations. Here you've got Al2O3, which is aluminum and oxygen. I write out those items that I have on each side and I count them. Al2 is 2, O3 is 3. On the other side, I've got Al and O. There's 1 and 2. Notice neither one of them is balanced, so we have to add coefficients in front of the different parts of our equation. Now, to do this, again, we want to think about adding to the largest part first, because then we can always go back and add to where the equation is a little bit simpler. Notice there aren't any other things that are attached here in terms of these molecules. I'm going to add in front here because I have 2 aluminums, and I want to get this oxygen to a level of even numbers. That way the even number on this side can match up. So what times 3 is going to make that an even number? If I add a 2 here, I'd have 2 times 2, which would make the aluminums 4, and 2 times 3, which would make this a total of 6. Notice how I made those into even numbers. That way on this side, I can increase those as well to make them even. The aluminums need to go from 1 to 4. I would put a 4 here then, and the oxygens need to go from 2 to 6. I say 3 times 2 is going to give me a total of 6. I recount those. I get 4 aluminums, 6 oxygens, 4 aluminums, 6 oxygens, and I've got a balanced chemical equation on both sides. In this example, Fe is iron. You've got hydrogen and oxygen, so we now have 3. I don't think any of the equations we did before had 3 different sets of elements or 3 different elements to go through. In this case, we have to do the same thing. We count out how many elements are on each side of the equation. Fe is 1, that's 1 iron. H2 means 2 hydrogens, and no subscript or coefficient means there's 1 oxygen. Here you've got Fe3, O4, and H2. Notice you don't have any of those that match up. What are you supposed to do in this case where none of those items match? Now, Mr. Shane mentioned that it might be beneficial to try and change the largest of those items, but in this case, the largest compound in this equation actually has the most number of those elements. So there's already a greater number of irons in this side of the equation than there is in this side. So it doesn't make sense to change this and then overwhelmingly change this, because just like in math, when you want to reduce a fraction, balanced chemical equations want to be in that reduced form. So I don't want to just add numbers here and then have to really increase this if I have a common denominator between those, how many I can add. So I'm thinking that I need to get this level of lesser elements to increase and match this. If I've got 3 here, let's see what happens when I put in a 3. Now, I'll remind you, some of this might be trial and error. I might have to put in a number and then count. If I don't have an equal number, I might have to actually cross this out and erase and then go back and try again. So 3 of those is going to change this to a 3. Now those are balanced. Is there anything I can do to the H2O and to the H2 on both sides to make sure my hydrogens and my oxygens balance? It looks like on this side I've got 4 oxygens, which doesn't necessarily need to be changed on this side, but here I only have 1 oxygen. Well, how would I change that from a 1 to a 4? If I'm thinking about multipliers, to get from 1 to 4, I would just put a 4 in this location. 4 times 1 is going to change that to 4, but then that 4 times 2 changes this hydrogen to an 8. Now I've got 2 hydrogens and 8 hydrogens. I need to increase that. I've got 4 oxygens and 4 oxygens and 3 irons and 3 irons. So the thing I need to change is the hydrogens here, which means I'm adding a coefficient to this location. If I've got 2 and I need to have 8, I would put a 4. All right. Now Mr. Shane's probably done this many times in terms of what's called stoichiometry or balancing chemical equations. So he doesn't really have to go through this guessing process that you might have to when you're working through this. What I would like you to do on your own is to try to solve these last 2 most difficult equations. I'll set it up for you. Here you've got a carbon, a hydrogen, and an oxygen. A carbon, a hydrogen, and an oxygen. And you're going to first count the number of elements on each side and then work to add coefficients to make it balance. What you might need to do is with a pencil, write in a number here, take a guess, recount. If it doesn't work out, you might have to erase that and then try again. Okay, a little trial and error. You add a number, count, try again. Add a number, count, try again, so that you have a balanced set of chemical equations. Use some of the tips that Mr. Shane gave you in terms of how to set those, in terms of making even numbers or making sure that the lesser numbers can make a larger number match in that case. The most difficult one, what looks like to be the most difficult equation here, is this equation down at the bottom. It's actually not as difficult as it might seem, and I want you to try it out on your own. See, you've got sodium, sulfur, oxygen, calcium, and chlorine. You've got 5 elements on each side. Now when I write these out, I want to make sure that I write these out so that they're across from each other so I can see that. So I got sodium, sulfur, oxygen, calcium, and chlorine. And I'm going to add coefficients to make sure that I have those balanced set of chemical equations. Now in this case, this bottom one, I'll do the first initial counting for you, and I want to see if you can go ahead and add a number to the coefficients to actually make these equal. Let's count on this side. You've got Na2, and there are no other Nas, so you've got 2 sodiums. S, you've got 1. Oxygen, you've got O4. Ca, calcium, you've got 1, and Cl2, you've got 2. On this product side, you've got Ca, which is 1, S, which is 1, O4, which is 4, Na, which is 1, and Cl, which is 1. Notice the differences that you have are in Cl and Na. Is there any way that you can change both of these on this side to match this side? I'll give you a hint. There's only one coefficient that needs to go into that equation. I'd like you to do those last 2 on your own as your assignment. God's blessings.